So in this video, I'm giving a very quick overview of the solutions to Quiz 5 in Math 165. The full solution is posted on Canvas, and there are videos associated to sections 5.3 and 5.4 that discuss this material in more detail. All right, well, let's get right to it. Problem number 1a. We are taking the derivative of the integral from 1 to x squared of the natural log of t. Now, the first part of the fundamental theorem of calculus, FTC1, tells us that the derivative of the integral is just the function that we started with. So the function we started with was the natural log function, and we evaluate it at x squared. Now, because the x squared is some function of x different from just x, we need to apply the chain rule and take the derivative of that function. So the derivative of x squared is 2x. And so the answer here is the natural log of x squared times 2x. And that's by FTC1. Plus the chain rule. Okay, now in part B, we're just computing a definite integral, and we could, if we wanted to, go back and use a bunch of rectangles, but why do that when we can use FTC2, which tells us that we can evaluate integrals like this just by computing antiderivatives. So first of all, we need to simplify the quotient. So the quotient there is x to the 3/2 plus 1. And then if we apply FTC2, so here the integral goes from 1 to 2. We apply FTC2, this is 2/5 x to the 5/2, just finding an antiderivative now. And then antiderivative of 1 is x. And then we want to make sure we evaluate that between 1 and 2. And when we do that, we're going to get a number, and it's about 2.86. I would put the exact number there, but there's not enough room on the slide. Okay, now in part C, we're asked to compute an indefinite integral. So our answer, instead of being a number, is going to be just a general antiderivative of 1 over 1 plus x squared. And we might remember, say from section 4.9, that arctangent of x is an antiderivative of 1 over 1 plus x squared. So to get the general antiderivative, I just take arctangent of x plus c. Okay, so that's problem number 1. Now, problem number 2, we're given a graph. So we're given this graph, y equals v of t. And we're asked to do some things with that graph. So the first thing we're supposed to do is compute s of 4. And s, you might notice from the statement of the problem, is the accumulated area function. So s of x is the area you accumulate under y equals v of t from t equals 0 out to t equals x. So for s of 4, I want sort of this accumulated signed area that I get under y equals v of t from t equals 0 to t equals 4. So if I first go out to t equals 2, I might notice that I have canceling signed areas of this quarter circle and that quarter circle. So those areas are equal. One is below the x-axis, the other is above the x-axis, and so their combined contribution to the signed area is going to be 0. And so all I want to do in the very first computation then is to compute the area of that rectangle, which is equal to 2. So s of 4 is equal to 2. All right. Now, the next problem asks us for S prime of 3. And remember, according to FTC Part 1, S prime of x for any x is just equal to the function inside, v evaluated at x. So for S prime of 3, right, S prime of 3 is v of 3. And so I look at 3 and I go up to the graph and I see that the height there is 1. Right? Likewise, S prime of 1 is v of 1, and v of 1 is 0. And then finally we have S double prime of 3. S double prime of 3 would be v prime of 3, which is the slope of the tangent there at 3, and the slope of the tangent is 0. So the answers to A, B, C, and D are 2, 1, 0, and 0, respectively. Okay, finally we look at problem number 3, where we're given a particle moving in a straight line with velocity v of t, where v of t is the function that's graphed in the previous problem, namely problem 2, and we want to know the displacement of the particle over the time interval from 0 to 4 and the distance traveled. So in part A, which calls for the displacement, we might remember that that's just simply the area under the velocity function, right? And so that's the integral from 0 to 4 of v of t dt, right? So that's just the signed area under v of t, which is given on the previous problem. And that's the we saw in problem number 2a that total signed area winds up being 2. Remember that the areas of the quarter circles cancel each other, and then we're just left with the area of the rectangle, and its area was 2. Now for part B, if we want the distance traveled, you might remember from the 5.4 video that instead of integrating the velocity, we want to integrate the absolute value of the velocity. Right? And now, how do you do that? Well, if you go to the picture on the previous page of v of t, imagine what the area under the curve would be if all of the curve were above the t-axis. So if you wanted that area, what you would do is you would add together the areas of the 2 quarter circles. So the 2 quarter circles each are of area pi over 4. And then you would have the area of the rectangle, which is of area 2. And you add those together and you get pi over 2 plus 2. So I guess it's calling for displacement and distance, so we should give some units. Here the displacement is 2 meters and the distance is pi over 2 plus 2 meters.